It's my pleasure to welcome Pierre Gelpi on stage. So Pierre Gelpi is in charge of business development for LoRa at Semtech, and he will be introducing LoRa solutions for smart logistics. So Pierre, the floor is yours.
Thank you very much, Ambroise. Let me share my screen. So thank you again, Ambroise and Must, for inviting me and having me today with you. I'm very happy to be here and be able to share LoRa solutions for logistics. That's the title of the presentation. I'm Pierre Gelpi. I'm in charge of business development for LoRa at Semtech. And I will start by talking about the LoRa technology. Maybe not everybody is familiar with the details, so I will spend a little bit of time on this first. Then I will move to really logistics solutions, what we have available today. And finally, I will share some examples, some customer stories, customer examples from real life. Just to introduce LoRa technology and give one figure, today we have almost 200 million connected devices around the world. So this is a proven technology that is working. We have passed the step of is it working? We now have a lot of networks. I will share more details about that. We have lots of networks, lots of customer projects, lots of ROI and value provided to end customers, and of course that's the goal. Another key point is that we have a lot of flexibility, both on the technical and the business model side. I will give more details later, but it's very important to understand that there are public networks like cellular networks that we know, also private networks, more like what we know with Wi-Fi. You can set up your own network very easily. And there are a lot of different other combinations between both extremes. Again, I will come back to that. And another very important point is the ecosystem. All these technologies are very good, but without an ecosystem, there is no chance of scaling and no chance of really being affordable for the end customers and provide solutions. So we are very proud of the LoRa Alliance ecosystem that we have in the LoRa world. With hundreds of members and a very active ecosystem. So in terms of networks, just to start with that, today we have networks in more than 170 countries and more than 150 operators. Right, so this is not an emerging technology anymore. It is really everywhere. There is no doubt about that. In terms of number of devices, as I said before, also in terms of number of networks, it is really really present everywhere. The green part is the ones that have public network roaming, right? So we'll come to that. It's very important also for logistics and coverage during transport to have multi-country networks. And roaming is one way to have multi-country networks. That's not the only one, because you can have also community networks that are already multi-country, but roaming is still important. I was talking about the LoRa Alliance. So here you have some logos with the different members. You see very big names on the left of the slide. We have sponsor members like Alibaba, Amazon, Cisco, and others. Even in the other categories, you have very important players. So that is key. It's not only one type of companies, right? It's not only hardware companies like Semtech, but also you have cloud companies and you have operators also like Orange and others who are very important. That's the most technical slide, so I think it will be okay. Just to explain how it works, because it's quite different from what we are used to if you are not familiar with LoRa. So the idea from the left to right is that sensors broadcast their messages. The communication is initiated by the sensors, and then the messages are collected by one or several gateways. But the intelligence is really in the network server that really receives the message in the end, and then forwards to the application. And the application is the only one that is able to decode the payload of the sensors, because the security is very important and is separated from the network and the application. This architecture is really, I would say, the most cost-effective way to collect data from sensors. And low power is very important. Hanan, you were mentioning low power hardware. I think we are one of the best examples of low power hardware to collect a lot of data from sensors. Again, this is more details about what I was mentioning between different types of networks. So you can have your single site, single gateway, like a Wi-Fi access point. You just plug the gateway, it works. You can have, of course, multiple site network, like if you have, in this example, 6 restaurants, you can have your network across the 6 restaurants. You can have a very large campus, and talking about transport and logistics, all factories, distribution centers are following this model, a kind of campus site. So with 2-3 gateways, you cover 1 square kilometer factory, indoor, outdoor, with no doubt on the coverage. That's again very cost effective. And then, of course, you can have your nationwide networks, or and roaming between nationwide networks, or you can have multi-country community networks like the Things Network or Helium that we know today. Just the key features very briefly. Long range, that's the definition of LoRa, right? So outdoor you can have tens of miles, and it also means very deep indoor coverage, meaning that it will cover hundreds of meters around the building and even in the other buildings. So it's indoor to outdoor to indoor for the surrounding buildings. Low power is key. It's really by design from the beginning. Battery lifetimes is guaranteed for more than 10 years for water meters, for instance. It's really very important. Multi-usage, we've spoken about different types of networks, but of course it can be also several roles using the networks. And in the end, all this results in a very cost-effective infrastructure, very low TCO for the end users. More details, bidirectional is key, because of course I was talking about both messages or data broadcasted by sensors to the network, but downlink is possible. Okay, the network can talk to the network. I mean, the network can talk to the devices, sorry. Also, the standardization is key. That's the first mission of the LoRa Alliance, to standardize the LoRaWAN protocol. It's an open standard. It's very important. Security is key for all IoT technologies. So in LoRa, it's very important. And I mentioned briefly that the network and the application is separate. I think that's one of the main principles, but it's also very difficult to jam because it's working under the noise floor. So really security is very strong. And location, we'll come back to that, but indoor-outdoor geolocation is very important, especially for logistics and transportation solutions. So coming to these solutions, here you have a matrix with two dimensions. One dimension is coverage. I mentioned the different coverage options, right? Private networks. You can have moving gateways in trucks, trains, or planes. or boats, because they can even be battery powered. You can have public networks, nationwide networks, that's of course obvious, and then multi-country networks. We have also satellite networks today, because long range means also that you can have sensors talking directly to satellites. So that's another option to cover the whole planet. Coverage options is one direction. The second option is features. The first one is presence, only presence. To have an automated inventory, you only need presence. Then geolocation is key for logistics. Ambroise has been talking about that in the introduction. It's very important, both outdoor and indoor. Right, and then you have additional features. I only mentioned temperature here, but you can have shock, vibration, a light for door opening, etc., etc. You have additional features, and depending on the user's role in the industry or the sector within the logistics vertical, you can find the right combination for you. Right, for instance. On the top left, the easiest use case is automated inventory for automotive or aviation suppliers. It already provides massive amount of value. I will show an example later. For perishable food in retail or healthcare, like vaccine transport, of course, you need cold chain, so you need temperature. And for instance, for pallet pullers, who are sending pallets from where the goods are produced to where they are consumed, and then they come back empty doing loops. So for these guys, you need most of the time multi-country networks. And so all these combinations are available somehow. Digging a little bit more into geolocation, again, several combinations are available. LoRaWAN will not solve the geolocation alone, for sure. So, but combined with other technologies, it's really powerful. So LoRaWAN alone is what is called TDOA in this table here. Basically, you don't need anything more in the device, because it's a triangulation of messages that are received by several gateways. So it cannot be lower power than that. It's great, but sometimes the accuracy is not enough because it's only hundreds of meters. So for outdoor, if you need more accuracy, GPS is one possibility because it has a lot better accuracy. The drawback could be battery life, but now with the LoRa Edge product, you can have very low power GPS. LoRa Edge, and the first product is called LR1110, has GPS, Wi-Fi, and even BLE. So you can have a GPS for outdoor. For outdoor, you can also use Wi-Fi. It will give you a few tens of meters of accuracy, Wi-Fi sniffing. It's at least in urban areas, and the benefit is that it uses the existing Wi-Fi access points. So moving to indoor, you don't need additional infrastructure, which is very important. But if you want more accuracy, then you have BLE. In this case, you need additional infrastructure. You cannot get around that, but you will have better accuracy. And again, it's also available in the LoRa Edge product. So, talking about the LoRa Edge product, I mentioned it very briefly. That's the latest chip from Semtech called LR1110. Who includes not only the LoRa transceiver, but also Wi-Fi and GPS sniffing. And it combines all of this in a smart way to provide geolocation services. The computation is done on the cloud to save power. Talking about logistics, here you have a simple diagram, I would say, about the logistics chain. It reads from left to right. Of course, there can be loops. I mentioned returnable assets or pallets before, and pallet pullers. In this case, they are loops. So not everything goes in one direction, but it's just to illustrate From the left, you have the factories where the goods are produced. Then the flows are aggregated in distribution centers. So the initial transport is local, usually done by trucks, and then it's aggregated in big warehouses. Between warehouses, there is often long distance transport that is either done by plane, boat, train, or can also be truck. Of course, this has impact on the requirements for the technology, because for air transport, you need specific certification for the trackers. And for maritime transport, you need a long battery life for at least 2 months. That is not really long for LoRa, but at least 2 months battery life. And then the last mile distribution is again using trucks, right? So the message here is that LoRaWAN will not solve everything, a little bit like geolocation. Ambroise mentioned the LTEM and the manufacturing. What is the progress of the manufacturing process? So they can improve the lead time because they save time in finding the boxes, but they can also improve the prediction about the lead time, which is very important for their customer relationship. Another example is automated inventory for automotive manufacturers. I mentioned it very briefly before, but that is key. These guys are spending millions of euros per year to replace these racks, these big metal racks that are the returnable assets they are using to carry the parts. And by having an accurate automated inventory with removing the manual scanning and manual mistakes that go with it, they are really saving this replacement OPEX. So the ROI of this solution is a few months because again, the solution is relatively affordable. And you have additional benefits because these racks are doing loops. So you can also do the same number of loops with less capex, less racks, if you reduce the stock of empty assets. The yellow part that you see on the graph, that is 1 week when the racks are not moving. When you reduce this, you can do the same number of loops with less capex. And you can also reduce the downtime at the assembly line because you have better visibility on when the racks will arrive at the assembly line. And then reduce the downtime that is generating a lot of cost also for the automotive players. Another use case in the vehicle industry is this outdoor tracking of trucks. At the end of the manufacturing process, all the trucks look the same, so it's very long to find them. Because, of course, they have IDs, but you have to look for the correct ID. So having the parking lot accurate geolocation, they have saved a lot of time in finding the correct truck. Customize it. Another example in the railway industry with a Deutsche Bahn who is monitoring the stocks of lubricants. So it's not about the cost of the lubricant, of course, but more about the downtime of these high-speed trains, because if they cannot start because of maintenance, then it's generating a lot of costs for the railway companies. And we have other examples in the railway industry with SNCF and others. In the oil and gas industry, also Chevron has rolled out, and here it's the perfect example of what I was mentioning before. These are areas where you don't necessarily have coverage, and LoRaWAN is really very easy to roll out in big fields like this because it will provide great coverage for a very affordable solution. Another customer example is worker safety with Accenture and Actility. And we can extend that, by the way, to COVID social distancing that is coming right after that, and that is also using the same kind of solution, because you can have worker tracking somehow, and if something happens in these factories, they can find the workers. They can make sure that they don't go in the areas where they don't need to go. And same thing for the COVID distancing. They can also make sure and have reports on who was present when, and make sure that they respect the distance. Another example is airports. We have talked about air transport, or we have trackers for air transport, of course, but an airport is like a city, so you have multiple use cases in an airport. It's and again, it's an area that is very easy to cover, and you can have thousands of sensors talking to one gateway that is providing coverage in a very large area. This is the example of Istanbul, but other airports, of course, also have LoRa networks. And I will finish with maritime transport with two examples. This one was announced a few months ago already. Wilhelmsen, the Norwegian player that has chosen LoRa 2.4 gigahertz for really both transport and condition monitoring of the boats worldwide. And more recently, Y-Track that has rolled out this project for Bermuda for end-to-end food monitoring between Canarias Islands and mainland Spain, including perishable food like bananas. So they have rolled out this solution, of course, to save the cost of losing a tracker because of a cold chain problem during transport. And we have done tests at 2.4 also on the container ships, and it's a little bit counterintuitive, but 2.4 has even better coverage than the sub-gig in container ships. So, and in addition to that, it provides a global solution. And in this case, it allows them to have a dual mode solution, either for regional transport or global transport, which is great. That is what I wanted to share with you today. Thank you for your attention, and I will welcome any question.
Okay, thank you very much, Pierre. Sorry, we'll be doing a few questions for your presentation. Pierre, maybe the first question we have is, what exactly does it mean to have GPS in LoRa? Is this provided with a LoRa stack?
So GPS is a separate radio, of course. So what I was mentioning is that in our latest chip, you have both radios in the same chip. So you can have the normal LoRa communication. And I have lots of background noise. I don't know if it's for everybody, but I hope it's not coming out. It's a lot better. So yeah, it's two separate radios. In our latest chip, you have of course the LoRa transceiver. You can do the LoRa communication, but you can also sniff the GPS from satellites, so that you can compute the geolocation. So it's in addition, I would say, to the LoRa transceiver, to the LoRaWAN stack that you can have on a modem. It's additional algorithm just to compute geolocation in a very low power fashion, because you do only sniffing, and it's a very low power option to have GPS.
Okay, thank you very much, Pierre. Maybe we have time for just one more question. The question says that the logistics is a good use case, but also maybe hybrid mode of combining LoRa and cellular connectivity. So is there anything special being done from the LoRa perspective to support a hybrid with cellular?
Yes, of course. I was mentioning LTE-M. It's a great backhaul. So I know, for instance, that Deutsche Telekom has announced a solution like this with the LTE backhaul and the LoRa. So in case you don't have a LoRaWAN network available and you have LTE-M, that's a great solution to have a cost-effective way to collect data to the gateway, but then for the backhaul you use LTE. So that's a great example. And of course, yes, it's available. You have gateways that have LoRaWAN gateways that have LTE and backhaul capability.
Okay, thank you very much, Pierre.